Okay, Unit 2, comparative study of S and P block elements and their important compounds under BSc second year, Tribune University, Institute of Science and Technology. This is the curriculum of Unit 2, comparative study of S and P block elements and their important compounds. S block elements, the elements in which the last electrons entered in the s orbital of the valence shell, that is, ns orbital, are called s block elements. It consists of two groups, group first A, alkali metals, and group second A, alkaline earth metals. Okay, the alkali metals group first A, lithium, sodium, potassium, rubidium, cesium, francium. Lithium, sodium, potassium, rubidium, cesium, francium. This is the atomic number and this is the electronic configuration. General valence shell configuration, ns1, francium is radioactive element. These elements are also called alkali metals because their oxides are hydroxides, produces strong alkali in the aqueous solution. Periodic properties of alkali metals group first A, atomic radius. These elements have largest atomic radius in corresponding period in the periodic table. The atomic radius increases on descending the group from lithium to cesium. This is due to addition of extra shell with electron at each step from top to bottom. Ionization potential or ionizing energy. Since alkali metals have largest atom, that is size, those elements have lowest ionizing potential in corresponding period in periodic table. Ionization potential decreases on descending the group from lithium to cesium due to successive increase in their atomic radius. The first ionization potential are sufficiently low, but second ionization potential are extremely high. This is because after removing an electron, the metal cation attain the most stable noble gas configuration. The second electron has to be removed from the closed shell, that is octet configuration, which requires very high energy, even higher than the nearest noble gas. Hence, all alkali metals have monovalent cation, and formation of divalent cation is impossible Under normal condition, this metal loses one electron. Metallic or electropositive character, general electronic configuration, NS1. The tendency to lose electron is metallic property. The element having high tendency to lose electron and form cation are called metals or electropositive elements. The alkali metals have NS1 electron on the valence shell. So these elements have strong tendency to lose their NS1 electron and thereby attain most stable noble gas configuration. Hence, the elements are strong electropositive in nature. Electropositive elements in periodic table, metallic properties of these elements increases from top to bottom. This is due to increasing atomic size and decreases in ionization potential on descending the group lithium to cesium. And cesium is the most electropositive element in the periodic table. Electronegativity, non-metallic property. These elements are the most electropositive elements in periodic table. Hence, these elements are very low electropositive value, that is the very low tendency to gain the electron and form an ion. Group first element shows univalent, largely ionic and reducing agent due to following reason. Group first elements forms monovalent cation. Group first elements have only one electron and S1 on the valence shell. So these elements have high tendency to lose valence electron and to attain most stable noble gas configuration. The first ionization potential is very low and hence it is radially form monovalent cation. After removing the electron, plus cation attain the most stable noble gas configuration. So these elements have no tendency to lose the second electron. The second ionization potential is so high that removal of second electron is not possible under normal condition. Hence, these elements do not form divalent cation. Compounds of group first are largely ionic except lithium. Compounds of group first are largely ionic except lithium is explained on the basis of two facts. On the basis of electronegativity difference, group first elements have very low electronegativity. These elements, when combined with the non-metals in most cases, their electronegativity difference exceeds 1.7 and hence they form predominantly ionic compounds. On the basis of Fazan's rules, the ionic size of these elements are largest in periodic table. According to Fazan's rule, large cations have very low polarizing powers, hence form predominantly ionic compounds instead of covalent compounds. Large cations have very low polarizing power. Alkali metals are strong tendency, alkali metals are strong reducing agent. Group first elements have strong tendency to lose electrons and form metal plus cation. Since these elements, metals itself oxidize into metal plus cation axis reducing agents. Metals as the reducing agent. Group first elements have large negatives strand rate reduction potential, which means tendency to lose electron in high electron is high. Hence, these elements have strong reducing property. Hydration energy, the amount of energy released when 1 mole of the gaseous cation is dissolved in water to form hydrated cation is called hydration energy. The amount of energy released when 1 mole of the gaseous cation is dissolved in water to form hydrated cation is called hydration energy. Metal cation, water, metal S2 energy release called hydration energy. Hydration energy of cation depends on the degree of hydration, number of water molecules that surround the cations, which depends on the charge density. charge over radius of the cation's hydrogen energy and degree of hydrogen is directly proportional to the radius of cations. It means smaller the cation's charge remain constant as plus one, have high degree of hydrogen and high hydrogen energy. Since cationic size increased on descending the group where hydrogen energy decreased from lithium to cesium, that's why lithium is most extensively hydrogen amongst the alkali metals.